Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A meso compound is an achiral molecule that contains two or more stereocenters but has an internal plane of symmetry, making it optically inactive despite having chiral centers. Moving on to the next step. Identify which compounds have two or more stereocenters. A. To chlorobutane, only one stereocenter, C2. Cannot be meso. Eliminated. B. 2,3-dichlorobutane, two stereocenters at C2 and C3. Structure CH3, CHCl, CHCl, CH3. The two end groups, CH3, on either side are identical. C. 2,3-dichloropentane, two stereocenters at C2 and C3. Structure CH3, CHCl, CHCl, CH2CH3. The groups on C2, CH3, and C3, CH2CH3, differ, so no internal plane of symmetry is possible. Cannot be meso. D. 2-hydroxypropanoic acid, lactic acid, only one stereocenter, C2. Cannot be meso. Eliminated. Moving on to the next step. Check 2,3-dichlorobutane for meso form. The molecule is CH3, CHCl, CHCl, CH3. C2 has substituents Cl, H, CH3, and CHCl, CH3. C3 has substituents Cl, H, CH3, and CHCl, CH3. Because the molecule is symmetric, same groups on both ends, CH3, there exists a stereoisomer where C2 is R and C3 is S, or vice versa, giving an internal mirror plane through the C2-C3 bond. This R-S stereoisomer is the meso form. It is superimposable on its mirror image and is achiral. And for the final step, why other options fail? A and D have only one chiral center, so meso is impossible. C. 2,3-dichloropentane has two different substituents on either side, CH3 versus CH2CH3, so no internal plane of symmetry can exist, no meso form is possible. Therefore, the correct answer is B. Therefore, the correct answer is option B.